back to my channel. In today's video, we shall be answering some of the 2025 likely physics exam questions you must take note of as you are preparing for physics in any of your forthcoming O-level exam. So without wasting time, guys, we'll be getting started now. Now let's look at question number 1. It reads, two simple pendula A and B make oscillation of 200 and 300 respectively in equal time. So emphasis should be on what? Equal time. So let's see what we have here. Equal time. We'll mark this. They now said if the period of A is 1.2 seconds, calculate the period of B. Now if these guys oscillated in equal time, what will be the period for B? That is what we are asked to find. So without wasting time, guys, we'll be getting started now. So solution. Let's see what we have to do to get the answer to this. Now first thing first, what is the formula for period? And before we even do that, let's derive all that was given in this question. They said two simple pendula A and B, okay, make oscillation of 200 and 300 respectively. So if it was written as A and B, it means that 200 goes to A, 300 goes to B. That is what respectively means here, okay? So when they say respectively, the order at which they arrange this is the order at which the others will follow, okay? So A to 200, B to 300. And remember they said make oscillation. How do we represent oscillation in physics? It's N, okay? So this will be N subscript A. For N subscript A, it's what? 200. Is it not? Then for N subscript B, it will be what? 300. So we'll put 300 here. Okay? Then what else? In equal times. So T A is equals to what? T B. That is what equal times means. The time taken for A to make its oscillation is equals to that taken for B to make its oscillation. Then what else? They said if the period. Now the sign or the symbol for period is different from that we use to represent time. For period, it is capital T. They said if the period of A will be represented as capital T subscript A. They said it's equals to what? 1.2 seconds. 1.2 seconds. Now what is the question? Calculate the period of B. T, capital T subscript B is what? Unknown. So this is all that was given in the question. Okay? Go through it and see that this is all that was given. Now, the question you need to ask yourself before we start solving. What is the formula for period? Because it's the formula for period we can actually use to solve this question. We know that period is equals to small t over small n. Big T, period, is equals to total time taken for oscillation over the number of oscillation. Now, we were told in this same question that the time taken for A and B to make their oscillation was equal. So observe something. If this is true that T is the same for A and B, we can actually say that T is directly proportional to N because we assume that what small t is constant. Okay? And if this is an inverse proportion, we can get something like this. Capital T1, N1 is equals to what? Capital T2, N2. How did I get here? Observe something. Let's make small t subject. This will be equals to what? Cross multiply. Big T times small n. Small t is equals to what? Big T times small n. Is it not? And we know that this small t is constant. So if we have T1, N1 on this side, and we have T2, N2 on this other side, it will be what? Equals to each other. Okay? Because we assume that small t is constant. Is it not? So let's see how this will now work from here. In this case, we're not given as pendula 1 and pendula 2. We're given as A and B. Is it not? So I will change it now to A and B. A and B. So if this is what we now have, how do we now find TB? We will impute the values of all we have into this to see how we can make TB subject. So watch out. In place of TA, we have 1.2. So we'll say 1.2 times NA, we have what? 200. This will be 200. It will be equals to, what is TB? We don't know the value of TB yet, so it's our unknown. Then times, what is NB? The number of oscillation made by pendulum B. It is what? 300. So let's work this out from here. 1.2 times 200 give us what? 1.2 times 200 give us 240. So here we have 240 is equals to TB times 300. TB times 300. Now we are asked to find what? TB, the period of B. How do we now get it? If we have 240 is equals to TB times 300, what is advisable here is to make what? TB subject, is it not? How do you make TB subject of this equation? Remember, on this side you have TB times what? 300. So the best thing to do is to divide both sides by 300. Divide both sides. So this side will also be what? Over 300. Now watch out what will happen here. 300 will cancel 300. What will you have left on this side? On this side of the equation? To be just what? TB. TB will now be equals to what? 240 over 300. Okay, let's see what we now have here. TB will now be equals to, finally, 240 divided by 300. 240 divided by what? 300. And that gives us exactly 0.8 seconds. Remind you, for TA, it was given in seconds because period is a form of time. It is the time taken to make one complete oscillation. So when you are done finding your answer, here in this case is what? 0.8. The unit to add is what? Second. And this is the answer to this very question. I hope this is clear. You can go through it again and see how it was solved. So let's go to question 2, okay, without wasting your time. We read together, then we solve. They said, a girl makes 20 oscillations with a certain simple pendulum 3 times, okay? Not just 1 time, but she did that 3 times. And what happened? They said, and she obtained the following period. That's what actually was meant here. 45 seconds, 45.5 seconds, and 45.7 seconds. These are the different periods she obtained. Then I said, calculate the mean period of oscillation of the pendulum. We are asked to find mean period. First thing first, whenever you are given a physics question, what do? Ensure you derive all that was given in the question. So we go again. They said, a girl makes how many oscillations? N is equals to what? 20. Is it not? From the question. 20 oscillation with a certain simple pendulum. How many times? They said 3 times. So we can set let's just say sigma n. Let me just put it like this. How will I put it? 3 times. Okay, let's just continue like this. Then I said, and obtain 45.5 and 45.7 seconds as the different period. So let's just put it this way. T1 is equals to 45. T2 is equals to, okay, let me add second because it was given in second. 45.5 seconds for T2, okay? Then T3 is equals to what? 45.7 seconds. Now what is the question? Calculate the what? Mean period. Now we can call this capital T. Big T is what? Period. This sign here over it is showing the mean of the period. The mean of the what? Period. Now because we are asked to find the mean period, it is unknown in this place, is it not? From the question, we don't know what the mean period is. Now how do we now work with this out if this is all we know about the question? Now since this is unknown, let's write it out. Is there a formula we can use to actually get our, let's say, our mean period. Now from normal mathematics, whenever you hear mean, okay, you are summing something and dividing it by the sum of another, is it not? Let's say the sum of a set of quantity over the sum of another quantity. Now what quantity are we talking about here? This is about period. The normal formula for period is small t over small n. That is what we have here. Period equals small t over small n. So now because they are not saying mean period, we will now say sigma small t over sigma small n. This will now be the formula for what? Our mean period. Now, what does this sigma small t means? Okay, sorry, all this one will be small t, sorry. These are the different time. We are asked to find the mean period. We don't know the mean period yet. But we have our T1, T2, and T3. Our number of our time for the different oscillations, we have them here. Now, how do we now solve? If we are looking for mean period, and this is what we know that sigma small t means the sum of the different t, is it not? So because we have T1, T2, and T3, we'll say T1 plus T2 plus T3, everything over what? Now, sum of n. Sum of n. How many times did the girl made the oscillation? 3 times. So in the first time when she oscillated it, she have an n, is it not? In the second time, that is n1. In the second time, she had another n. And the third time she made the oscillation, she had another n. So n1 plus n2 plus n3. Understand something. She was trying to get the mean period. So the first time she oscillated the pendulum, she had T1 and she had n1. The second time she repeated the experiment, she had what? T2 and she had n2. The third time she made the experiment, that's why they said 3 times. The third time she made the experiment, she had T3 and she had n3. So how do you now find the mean period if this is what we have? Watch out. What is our T1? It is 45. What is our T2? It is what? 45 point what? 5. And lastly, what is our T3? It is 45.7. This is 7. Okay? Don't mistake it. This is 7. Now, everything over. Now, the first time she made the oscillation, how many oscillations did she make the first time? She said she made 20 oscillation 3 times. So in a nutshell, you can actually say 3 times 20. Or you say 20, because that was the number of oscillations she made for experiment 1, plus 20, because that was the number of oscillations she made for the second experiment, plus 20. That's the number of oscillations she made for the third experiment. So in total, it is 3 times 20. Now let's see what we will now have from here. 45 plus 45.5 plus 45.7. Let's see what we have. 45.5 plus 45.7. We have 136.2 over 20 plus 20, 40. 40 plus 20 is 60. So let's see 136.2 divided by 60. Let's see what that will give us. Our final answer for the mean period is that mean period is equals to, based on what I have here, 2.27. Exactly 2.27. And because period is a form of time, the unit to be what? Second. And this is the mean period. Just like saying the different time you got for 20 oscillation. You did 20 oscillation. You record the time. That is experiment 1. You did another 20 oscillation. You record the time. You got this. You did another 30 oscillation. You recorded the time. You had this. Now you're not finding the mean time using this formula. And this is what she got. So I hope you understand how question 1 and question 2 are solved. So we're back now. We're getting to question 3. Alright, here is question 3. It reads, A simple pendulum makes 30 oscillations in 1 minute. Now, what is the question? What is its period of oscillation? So say solution. Now, like I said, when you are given a question in physics, the first thing to do is to write out all that was given in the question. Okay? So we go again. A simple pendulum makes 30 oscillation. So our n in this question is what? 30. Good. 30 oscillation. Then I said in 1 minute. That is the time it takes for the pendulum to make 30 oscillations. So we'll say small t, not big T, but what? Small t, because that's the time taken. Now, what is the value? They said 1 minute. 1 minute. Now, in physics, especially when you are solving questions in physics, to be specific, the unit you use for time is second, not minutes, not hour, nor day. Okay? So whenever you are giving time in any other units, in any other form, the best thing to do before you start solving is to convert that time to what? Seconds. So how do you now solve from here? You are given as 1 minute. The best thing to do is to convert to what? Second. Now, when we are converting from minute to second, what do? You multiply by what? 60. So whatever you have as the number here, it will be times 60. In this case, we'll say 1 times 60. 1 times 60 is what? 60. So we'll be working with 60 seconds. I hope that is clear. We will not use 1 minute to solve, but we'll be working with what? 60 seconds, which is the equivalent. Now, what is the question? What is its period of oscillation? Period of oscillation, what is the symbol? Capital T. And in this case, it is unknown. So you have n, you have small t, and big T is unknown. Now, based on the unknown, we know that it is period that is unknown. So, what formula can we use when you are asked to find period? Because this is the unknown, that will determine the formula you should start with. I don't know the period. So, is there a formula for period that I can actually use? We know that period is equals to what? Time taken over the number of oscillation. So, we can actually start from here and start thinking how we solve. We don't know an unknown, then we'll start from there. Is there a formula for this unknown? And see how we can use what that was given and see how we can chip it into the formula. And that's what we are going to be doing right now. T is unknown, and this is the formula for T that we know. Now, do we have small t? Yes. Do we have small n? Yes. Can we now find big T? Yes. So we now say big T will be equals to, in place of small t, which is the time taken, we'll say what? 60 seconds. Mind you, we are not using 1 minute. We use the equivalent in seconds. So we'll say 60 seconds over, what is our number of oscillation? 30 over 30. Okay? We are working on it now. We can now say T is now equals to 0, we cancel 0. 6 divided by 3 is what? Exactly 2. Exactly 2. So we can now say the period of oscillation is 2. But do we stop there? No. We have to add the unit. What is the unit for period of oscillation? It's what? Second. And we are done. 2 seconds is the period of oscillation. So let's go straight to the next question. Question 4. We read, then we solve. He said, the period of oscillation, the period of a simple pendulum will increase by what factor? If the inextensible length increases by a factor of 4. The period of a simple pendulum will increase by what factor if the inextensible length increased by a factor of 4. So how do we solve this kind of question? It's a comparison question. If I increase the, let's say, the length by 4, by what factor will the period increase? We are doing some kind of comparison here. And this is the best way to do it. Is there a formula for period? Let's start from there. Because they are saying the period of so and so will increase by what? So it is period that is unknown here, is it not? Good. Now, we are going to be looking for the factor by which the period will increase. Now, we're told that, assuming there is L1, let's call our L1 L. Because this is where I like doing it best, when you are doing a comparison question. Assume there's an initial case and there's a final case for each. Assume there's an initial period and there's a final period. Assume that there's an initial length and there's a final length. Let's do that now. Assuming our L1, okay, let's do this way. Let's start from here. Assuming our L1 is symbol L and our L2, reading the question, they said, if it's inextensible length, what matters to us is an dimension length. So if its length increases by a factor of what? 4. So L2, a factor is a number that is attached at the front, okay? Definitely it's defined differently in mathematics, okay? The factor is of a whole number is kind of different. But now it's any number you put in front of a symbol or a letter, just to be basic. If the length increased by a factor of 4, so we'll say 4. What is the initial length? L. So L2 has increased by a factor of what? 4. Is it not? That is what they are saying here. And in mathematics, we say a factor is a number that can divide another number exactly without a remainder. In this case, it is the factor that will be in front. So when they said the length increased by a factor of 4, it means in front of the initial length, we introduce a number which is what? 4. Now this will now be our L2. Now let's go to the period. Assuming the T1, because I told you you will have an initial case and a final case. Let's call the T1 capital T. And our T2, because of the way the question was asked, the period of a simple pendulum is what? We increase by a factor of what? We don't know what the factor will be. So our T2 will just say it's unknown first, because we don't know the factor by which our T1 will increase. So assume this one you have initial L1, final L1, initial T1, final T2 is unknown. Okay, so let's solve. Is there a way we can find our T2? Mind you, T on its own is what? Period. So we start from there. Let's build up from there. T. Is there a formula for T which is period? Yes. What's the formula? T is equals to small t over n. But can we use that here? No, it won't work. Now mind you, there's another formula for period under simple pendulum. And what is that formula? T is equals to 2 pi root L over G. 2 pi root the length of the simple pendulum, everything over G, which is gravity. Now ask yourself, the relation we are trying to draw, is it between T and G? No. Is it between T and L? Yes. Okay? Now we know, bring this here. I want to put it in another form. That T, what we have here is the same thing as T is equals to 2 pi root L over root G. Is it not? I just share the square root. Give the square root sign to the numerator and also to the denominator. Now observe something. What is the relationship between T and L? We can see that T is directly proportional to L. Is it just L? No. But to the square root of what? L. Is it not? Good. Now this is what we now have. This is what we now have. Now we can actually work with this, okay? But we can put it in another form. Assuming you square this and you square this, what will you have? T squared will give you T raised to power 2, directly proportional to square, we cancel square root. What will you now have left? L. So this is another form of what we had here initially. Are you seeing that? This is another form of what we had here initially. And you can actually work with this. Now, since this is a direct proportionality, okay? Because we are going to be comparing two scenarios, an initial and a final scenario. If we were to put this in another form, we will say T2 over T1, everything squared. Are you seeing that? That is, the square is going to affect everything on this side. Will be equals to L2 over L1. Mind you, 2 and 2, they are on the same side as what? Numerator. Is it not? They are both on the same, they are on this both sides as what? Numerator. While 1 and 1 are on both sides as what? Denominator. That shows what? Direct proportionality. Now this side is carrying a square. That's why everything on this side should be raised to power of what? 2. This side is not carrying a square. So everything on this side will not carry a square sign. That is how it works, okay? That is how it basically works. So from here, let's progress. Ask yourself, is there a value for T2? T2 has no value. So we can leave it as what? T2, okay, let's rule this so we won't confuse it. Over, is there a value for T1? We said we should take our T1 as what? Big T. So over big T, everything squared is equals to, is there a value for L2? L2 is 4L. 4L over, is there a value for L1? L1 is simply L. So from here we progress. Watch out. What do we now do? Observe something. L can cancel L. Is it not? This L will cancel this L. Now what we now have? T subscript 2 over T raised to power 2 will now be equals to what? 4. It will be equals to 4 on this side. Now watch out. We are not done. We are asked to find T2 first. Is it not? How do you now get T2 from here? Now take the square root of what? Both sides. Square root of what? Both sides. Take the square root of both sides. Now this square will cancel this square root sign. What will you now have on this side? T2 over T is equals to what? The root of 4 is what? Exactly 2. Now we are not done. We will keep solving. We rule again. Now watch out. Watch out. Cross multiply. Because you are looking for T2. Cross multiply. T times T2. That will make T2 equals to, like I said, T is going to times 2. That will make T2 equals to what? 2T. Is it not? T times 2 is what? 2T. Now this is what we now have as our T2. But the question is saying, by what factor? Now like I said, the factor will now be the number in front. Is it not? So what is the number in front of T that we have here? Is it not 2? So the factor by which the period will increase is 2. So when you see option A, 3, option B, 2, option C, 4, option D, 5, the answer is what? 2. And that is how you get the answer to this very question. So back now, guys, we'll be taking the next set of questions. We'll be having them now. Alright, here is the next question. It reads, calculate the length of a displaced pendulum bulb that passed through its lowest point twice every 1 second. So we are asked to find what? The length of that pendulum bulb. So we'll be taking the solution. Now, first thing first, when you have a question in physics, derive what I was given in the question. So we go again. Calculate the length. L is unknown from this question. Now what else? Of the pendulum bulb that passes its lowest point twice. Now I want us to visualize what actually happened during the practical of this question. Assuming this is the pendulum bulb, okay? Now it was taken to this point, and then it was from here, they took the bulb to this place, and then they leave it. What will you observe? Once the bulb is released from here, it will swing this way and back and forth. Is it not? It will swing to and fro. To and fro. Now for every to and fro, the body has made one oscillation. And the time taken to make that one oscillation is equivalent to the period. So if the body was here initially, and it was made to fall through to this extent and to return back to this place, that is one oscillation. Not when the body got here. Mind you, one oscillation is when the body go to and return fro. You say 1, then 2, Now the time taken to go so and to come back through is equivalent to the period of the oscillation. I hope that is clear. So observe something about this question. They said calculate the length of a displaced pendulum bulb that passes its lowest point twice. Now, when this bulb at this point is made to fall and it passes through the lowest point twice, how many oscillations is that equivalent to? Let's get that. Initially it was here, then it starts falling. It starts falling. Now it has passed here through the lowest point, because this is the lowest point. Here is higher than here. This place is a bit higher than here, is it not? So at this point, it is what it is said to be at the lowest point. So when the body starts falling from this initial place, it starts falling. It has passed the lowest point once, it got to this highest point again, and start descending, start coming back. It has passed the lowest point how many times? Twice. So when it passed the lowest point twice and return here, how many oscillations is that equivalent to? 1, is it not? Because this is 1, passes through it once, then it has passed through the lowest point twice. And when you turn back, we say it's through, is it not? And that is equivalent to how many oscillations? 1. So we say our n is equals to 1. If they are said it passes through the lowest point 4 times, that will be equivalent to how many oscillations? 2. Check. 1, 2 oscillation, but it actually passes here 4 times. If it passes here 6 times, that's how many oscillation? 3 oscillation. If it passes through this lowest point 8 times, that's how many oscillation? 4 oscillation. And that is how it works. It's very, very tricky. Now watch, we are not done. That passes through its lowest point twice, that is 2 times, every 1 second. That is the time that is taking so far is 1 second. Are you seeing that? Now what is the question? Calculate the length of the displaced pendulum bulb. It was displaced. Are you seeing that? Now how do we now get the length? What is unknown? It is the length. Now when the question is about simple pendulum bulb, the first formula that should come to your mind under simple pendulum bulb is T equals 2 pi root L over G. This is the key formula when we are talking about simple pendulum bulb. Now ask yourself, in this formula, is there a place for L? Yes. Is there a place for N? No. Is there a place for T? No. Now what do we now do to get our T, big T? So we can actually use this formula to solve. There is another formula for period, which is what? Big T is equals small t over n. We can actually use this formula to get big T and then come back to use this formula. Is it not? Let's do that now. Let's get our big T. We now say big T is equals to, what is our small t? Our small t is 1. Then our small n is what? 1. 1 divided by 1 will give you what? 1. So this is what we have as our period. Now we have our period, that is big T, as 1 second. Okay, as 1 second. We'll now come back to this question, to this formula, and solve with it. We now say that instead of big T, we'll say 1 is equals to 2 times pi. What is the value of pi? Okay, what is the value of pi? But before we do that, let's leave it as 2 pi. 2 pi root, is there a value for L? Not yet, so we leave it as L. Is there a value for G? Yes, but let's leave it as G first. Now we are looking for L based on the question. So the overall goal is to make L subject, is it not? Yes, but we can actually do that step by step. Now in front of these roots, what do you have? 2 pi. Can we divide both sides by 2 pi so that we can be reducing what is here, so that in the end we'll make sure that L is on its own? Yes, we can divide both sides by 2 pi. How do that now look like? Over 2 pi, let me just do it like this. I will look like I did over 2 pi and over 2 pi. 2 pi we cancel 2 pi. then this will be equals to this. So we can now say 1, let me rule, 1 over 2 pi is equals to root what? L over G. L over G. Are you seeing that? Now how do we now solve from here? How do we now solve from here? We can actually get a single value for this, okay, before we continue, because we know the value of pi. Is it not? Or you can choose to continue first, then impute the value of pi later. But let's just get the value of pi and solve. 1 divided by 2 pi. We know that pi is what? 3.142 approximately. So let's times it with 2. What will we have? 2 times 3.142. We have 6.284. So let's say 1 divided by 6.284. We are going to get the overall value for this before we continue. 1 divided by 1 divided by 6.284. We have 0.16 is equals to root of L over, now in place of G, what is the value for G? G is approximately 10. Is it not? Good. Now we are going to be looking for L, but it is carrying a square root. How do we simplify? To remove the square root sign here, we what? Square both sides. So it will now be raised to power 2, raised to power 2. On this side, we take the square of 0.162. The square of 0.162, which is the same thing as 0.16 times 0.16, will give us what? Let's see what it will give us. We have 0.0256 equals to n over, what is? Over 10. Now from here we will continue further. We are asked to look for L. So how do we make L subject? Cross multiply. So whatever is there, we times what is up here. And whatever is there, which is assumed to be 1, we times what is up here. So what do we now have? 0.02856 times 10 is equals to L. So you cannot say L is equals to, whatever we get here will be the final answer. Let's say 0.02, okay, 56 times 10. Finally, L will be equals to what? If you do this with a calculator, you have 0.256. Are you seeing that? This is the what? Length that we are asked to find. Now, because it is length, what is the usual unit for length? It is what? Meter. And this is the answer to this very question. It is that easy. So we are going straight to the next question without further delay. It reads, a simple pendulum has a period of 4.5 seconds. Now, when the length is shortened, let's start deriving without wasting time. Okay? We can actually start deriving now. When the length is shortened by 1.2 meter, okay, the period is now 2.5 seconds. So it was assumed there was an initial length L. So when that initial length L is now shortened by 1.2, in mathematical expression, we will say L minus 1.2 to get the final length. Is it not? After you have removed 1.2, you have shortened it by 1.2. That means you have removed 1.2. Expression mathematically is now what? L minus 1.2 for final length. Is it not? The new period will now be correspondingly 2.5 seconds. Now, what is the question? Determine or calculate the original length. Now, this is how we work it out. We know that there was an initial length, L1. We represent it as L. Now, after they said that the length is shortened by 1.2 meter, we will now have a final length, L2. And that will now be what? L, is it going to be L plus 1.2 or L minus 1.2? The answer is what? L minus 1.2, because they said shorten. Shorten is like saying subtracting. When they say the length is extended, that is like adding. Is it not? I hope you get that. And this is what we now have as the expression for L2. Okay? Then I said the length is shortened by L 1.2 meter, and the new period. Now initially they said A simple pendulum has a period of what? 4.5 seconds. That is our T1. 4.5 seconds. Now after the length is now shortened by 1.2. Shortened by 1.2. Then I say the new period is now what? 2.5 seconds. So we'll call that T2. 2.5 seconds. Now what is the question? Calculate the original length. So from here, we are going to draw a relationship between T and L. Okay? We know that this can be expressed also as T is equals to 2 pi root L over root G. Okay? That's what we now have in another form. What is the relationship between T and root L? It is a direct proportionality relationship. T is directly proportional to root L. Okay? In another form, we can say, because if you square T here, you have T squared, and then if you square root L, you are going to have just L. This form is equivalent to this, and I like working with this form. Okay? So what do you now have? The square of T is directly proportional to L. Okay? Now, because we are comparing two scenarios, in another form, we can say T2 over T1. Now, initially, based on the relationship, it should carry a square. So T2 over T1 should be raised to power 2. Will now be equals to L2 over L1. Now, mind you, T2 is the numerator here, L2 is the numerator here. So they are on the same upper side of the equation. So that is direct proportionality. If it was inverse proportionality, while T2 is here, L2 will be here. While T1 is here, L1 will be up here. That is inverse. But if it's direct, 2, 2, 1, 1. Now because this L was not carrying any square, so I won't square this side, okay? Now we now have this. What do we now do? Impute the value of all you have here into this, okay? So let's continue with this now. In place of T2, what will we put? 2.5. 2.5 over, in place of T1, what will we put? 4.5. Everything should be squared, is it not? Bracket raised to power 2, is it not? Now, on this other side, watch out. L2 over L1. What is L2? L minus 1.2. What is L1? L. Now this is what we now have. Now the best thing to do the division of what you have inside. Okay? What is the value of 2.5 divided by what? 4.5. We have 0.5555. Now let's square it. Square. Okay, let me write it so you won't be confused. 0.56 if you approximate to 2 dp, 2 decimal place. Now that's what we got for the inside. So everything will be what? Raised to power 2. Is it not? Good. Everything raised to power 2. So I'll say bracket raised to power 2 equals to L minus 1.2 over L. Now let's square this again. 0.56 squared will now give us what? We have 0.3136. Approximate again to 2 dp. You now have 0.32. Okay? No, 31. Just being specific. So 2 dp we have 0.31. It will now be equals to L minus 1.2 over L. Now what do you do? Cross multiply. What you have up here will times what you have down here. What you have down here will times what you have up there. And if that is followed, 0.31 times L will give us 0.31, and the imaginary one under it times what we have there will give us what we have there, because any number times 1 is that same number. Okay? Like I said, 0.31 times L will give us 0.31 L. L. Take note. Now what next do you do? Collect like 10. Okay? Collect like 10. You can choose to bring all the L to this side and leave the ones without L on this side. Or you can choose to bring the one without L to this side and leave the one with L on this side. Whichever way, you still get your answer. So let's bring all the one with L to this side. Okay? So you now have 0.31 minus what? Because when L crosses to this side, it will become minus L. Then what will you now have left on this side? If you have removed L, what do you have? Minus 1.2, not just 1.2. There's a minus in front. That minus will still be there. Now what do you now have? In front of L, there's an imaginary 1. Are you seeing that? Because we need that one right here and right now. 0.1.3 minus 1. You are only going to be subtracting the factor. The factor in front of L here is 0.31. The imaginary factor in front of L here is 1. So 0.31 minus 1. 0.31 minus 1. That gives us minus 0.69. Now the identity here is L. That is the variable and it will remain here. Okay? You don't throw it away. You subtract the factor and you will add the L at the end. M2 now be equals to what? Minus, okay, negative 1.2. Now what do? Divide both sides by everything in front of L, because it's L we are looking for. If you divide both sides by everything in front of L, L will now be equals to what? 1.2, negative 1.2 over what was in front of L, minus 0.69. Are you seeing that? Now watch out. Minus will cancel minus based on what we know from maths. Minus will cancel minus. We now have 1.2 divided by 0.69. Let's get our answer. 1.2 divided by 0.69. That gives us exactly, not exactly though, approximately that will give us 1.74, because I like rounding off my answer to 2 dp. In physics, most times give your answer to 2 decimal place, and that is what we have, 1.74. And because it was length, what is the unit for length? It is what? Meter. So I will add m at the end, and this is the answer to this very question. Feel free to go through all of them again and see how everything was solved. So back now, we'll be going to the next set of questions. Let's have them now. Alright, here is the next question we are asked to solve, and it reads, an empty density bottle weighs 2 Newton. If it weighs 5 Newton when filled with water and 4 Newton when filled with olive oil, the relative density of olive oil is, and that is what we are asked to find. So we will say solution. We are getting started right away. We go again. And empty. Now when a bottle is empty, you know, based on what your knowledge of physics, there is still air inside, is it not? So when the bottle was empty and just contained only air, because in the earth there is no vacuum, is it not? You have atmosphere. So when the bottle was empty, there is air inside, and the bottle does not contain any other substance. The bottle at that instant weighs just 2 Newton. Okay, so we can say weight of empty bottle, or weight with just air, is what? 2 Newton. You can just say weight of empty bottle if you want to be easy. Okay? Now they now said if it weighs 5 Newton when filled with water. So the bottle was empty, then they now started adding water to fill it up to the brim, and then now weigh it again. This time around is now 5 Newton. Okay? So what is now the weight of the bottle with water inside? They said is what? 5 Newton. They now said and 4 Newton when filled with olive oil. So if that same empty bottle, they get another empty bottle of that same size, but this time they now fill it with what? Olive oil to the brim and weigh it. What did they got? Weight with olive oil inside the bottle was what? 4 Newton. And what is the question? Determine or calculate the relative density of olive oil. Now in physics, the symbol for relative density is what? Capital arrow and D. So arrow D is unknown for olive oil. I hope that is clear. We are also finding the arrow D of olive oil. Now if you have come across the lecture on relative density and density, you will discover there are different formulas for what? density and relative density, ROD. Now, based on the parameters we're given in this question, the formula we can make use of, because we are asked to find the relative density of olive oil, the formula we make use of is WO minus W in air over W water minus W air. Now, I will explain. Remember, we are working with a relative density bottle. So we are going to be subtracting the weight of the empty bottle. Normally, the formula would have used there, if we're not working with a relative density bottle, would have been weight of the liquid or the substance over the weight of an equal volume of water. That is simply WO over W subscript W. Now, because the bottle initially, out of this 5 Newton, the bottle on its own weighs 2 Newton. Out of this 4 Newton, the bottle on its own weighs 2 Newton. We have to subtract that so that we can get the actual weight of oil in the density bottle, and so that we can get the actual weight of water in the density bottle. I hope that is clear. So from here, we will now input our value. What is WO? WO is 4 minus what is WA? That is the weight of the empty density bottle. It is what? 2 over what is W subscript W? We have 5 minus what is W subscript A? We have what? 2. So we progress. ROD will now be equals to what? ROD will now be equals to, watch out, 4 minus 2 is 2 over 5 minus 2 is 3. Okay? Now this is it. Depending on the option, if the option was given as a fraction, this will be the answer. Or we can say our relative density of olive oil in another form, which is the decimal form, will be equals to what? 0.67. Mind you, you must approximate to what? Second dp. Now you may want to ask me, what is the unit for relative density? I will tell you that the relative density does not have a unit, because the first and primary formula for relative density is density of substance over density of air, or let's say density of water. In most cases, density of water. Now mind you, if you are saying density of substance over density of water, the unit for density is kilogram per meter cube. Over kilogram per meter cube, they will cancel out, is it not? So the quantity in physics, relative density, has no unit. So when you get here, this will be your answer and this will be your answer, depending on the options you are given. So we go straight to the next question. Solution. It reads, if the relative density of gold is 19.2. Now observe, in this place, was there a unit? No unit. That is to show that relative density does not have a unit. So ROD of gold is what? 19.2. So we progress. He now said, what is the volume of 2 kg of gold? 2 kilogram of gold. The volume of 2 kilogram of gold is what is unknown. But we're giving the mass of the gold as what? 2 kg. And in addition, we were asked to take density of water to be what? 1000 kilogram per meter cube. And we are asked to find the volume of 2 kg of gold using all these parameters. Now ask yourself, what is unknown? Volume is unknown, and the volume we are talking about here is the volume of gold. Now, how do we get volume of gold? Because this question is under relative density and density, we can use the first formula. Density is equal to mass over volume. Okay? Now, do we know the density of gold in this question? Because we are saying, in this case, density of gold is equal to mass of gold over volume of gold. This is the one they want us to get, volume of gold. We know the mass of gold, okay? You can say M subscript G. Do we know the density of gold? Mind you, we were given the relative density of gold, not the density of gold. So in this case, we have to get the density of gold before we can find the volume of gold. Okay? Now, how do we get the density of gold? We can use ROD because there was a value for ROD, that is relative density. Now, which of the formula for relative density are we going to be making use of here? We know the density of water, and we are trying to get the density of gold. So the formula to use is density of gold over density of water, and this formula will help us out. Okay, so once we are able to get our P gold, we can then fall back to this formula and solve with it. Now, what is ROD of gold? ROD of gold is 19.2. Is equals to, what is P of gold? P of gold is unknown. Okay, that is the density of gold is unknown. Now, what is the density of water as given in the question? They said is what? 1000. So let's cross multiply. P of gold will now be equals to 19.2. Are you seeing that? Times 1000 times 1000. Okay, let's see what we get. Times 1000. Let's see what we get. Now 19.2 times 1000 will give us what? This will give us 19200. And mind you, in kg per meter cube. This will now be the density of gold. So guys, we have gotten our density of gold. But that's what the question asked us to find. No, we were asked to find the volume of gold. The volume of 2 kg of gold. So we are asked to find the volume of gold. So now we know our Pg, our P of gold. We can now say P of gold is equals to mass of gold over volume of gold. Like I said, you can add gold, gold, gold if you choose. Okay? Now let's start imputing. What is P of gold? It is 19200. What is mass of gold? It is 2 kg. Now what is volume of gold? It is unknown, so it will remain V. Now let's cross multiply. We have 19200 times V equals 2. Now we are asked to find V of gold. How do you do that? Make V subject. How do you not do that? Divide both sides by whatever is attached to V. And what is that? 19200 over 19200. What will that now give us? This will cancel this. What is left on this side of the equation? Simply V equals 2 over 19200. And finally, V of gold will now be equals to, now depending on the option, there are two formulas, there are two answers we can get here. 2 divided by 19200. That gives us 0.000104 meter cube. Okay, I have to just manage the board. Now, in most cases, they won't give you the answer in decimal, because in JAMB and Physademy, when the number is like this or the figure is like this, they will just simply want to express it in standard form. So if this is our answer in decimal, let's now convert to standard form. How do you do that? You move this way. 1, 2, 3, 4. Now when you now have before the point a number that is significant, that is not 0. Okay, I move. It's before the point I have 0, so I won't stop moving. I move again. Before the point I have 0, so I'll keep moving. The third time, before the point I have 0. Then when I now move, and before the point I now have a significant number, e.g. 1, I will stop. So how many times did I move? 1, 2, 3, 4. So I will now say 1.04, or V is equals to 1.04 times, how many times did I move? 10. How many times did I move? 4. I won't say 4, I will say -4, because the number initially was 0 point. Okay, it was 0.000, so it will be -4. Then the unit of volume, meter cube. So this is the answer you see in the option. Okay, take note, this is how I solve. Either this or this, but most likely this, because they want to put their answer in standard form. So you are free to go over everything that I did solve for these questions. So back now, guys, you'll be receiving the last set of questions for for today. Let's get down to that. Alright, the next question reads, a body whose mass is 2 kg. Let's start deriving solution. A body whose mass is what? 2 kg. So M is equals to 2 kg. Then I said, and has a volume of 500 cm cube. V is equals to what? 500 cm cube. But is cm cube the standard unit for volume? No. So we have to convert from cm cube to what? Meter cube. And how do you do that? Simply divide by what? 100 or 1 million, okay? Simply divide by 1 million. That will give you 5 times 10 raised power minus 4 meter cube. Both of you that will be asking how I got this. This is 500 divided by 100,000. 20 we cancel 20. So 5 times, how many 0 do you have under? Is it not 4 of it? So because it's 4 of it, it will now be the reason why we have raised to power 4. But because the 4 is coming from under the dividing line, it will go with a minus. So 5 times 4 raised to power negative, 5 times 10 raised to power negative 4 meter cube. When you divide 500 by 1 million, you will have 5 times 10 raised to power negative 4 meter cube. In another form, your calculator will also give you 0.0005. It's still the same thing. You can work with that too. Now let's continue. They now said, just float when immersed in a liquid. Now what is the question? Determine the what? Density of the liquid. So we have to determine the density. P of the liquid is unknown. Let's say PL is unknown. Now, if you have studied the topic upthrust, or you say Archimedes principle basically, or fluid in motion, or equilibrium of body in fluid, depending on the way your textbook called the chapter. Now, you will notice there was a part we were talking about flotation. Now, they said the body just floats. This word float is what will guide how we solve the question. Now, because the word float was included in this question, it means this question is from flotation under equilibrium of body in fluid. Now, whenever a body begins to float, there is something that is true. The weight of the body that is immersed in the fluid is equals to the upthrust that the body will experience. So the weight of the body that is acting downward while inside the fluid is equals to the upward force called upthrust that acts on the body. When those two forces counterbalance, downward versus upward force, when they counterbalance, what the body will begin to do is to simply float. I hope that is clear. So from this, weight of body immersed in fluid is equal to what? Upthrust that is caused by the liquid itself. Now, from this, we can expand further. What is the formula for weight? Weight is m times gravity. We now say is equals to, what is the formula for upthrust? Because we were not given upthrust directly. The formula for upthrust we can use is P of liquid, that is density of the liquid that the body was immersed in, times gravity times volume of the liquid that was displaced. So you say VL or VI. Now why VL or VI? If the volume of the body that was immersed was given, you say VI. If the volume of liquid that was displaced was the one that was given, you say VL. So either VL or VI, they are the same thing. Because when the body begins to flow, the volume that is inside the water is equal to the volume that rises, that is the volume displaced. So VI, immersed, the same thing as VL, displaced. I hope that is clear. So because we are giving the volume of the body immersed in the fluid, I said VI. If they are said, if 500 cm of the fluid was displaced, I will say VL. I hope that is clear. It's that simple. Now from here, watch out. Do we have the mass of the body? Yes. Do we know what gravity is? We always know. Now do we have the density of the liquid? That is what we are finding. Do we know what gravity is? Yes. Now do we know the volume of the body that was immersed? Yes. So can we solve this question with this expression? Yes. Now I can choose to further simplify by saying G cancel G, because G appears on both sides of the equation. What will I now have? M would be equals to PL times times what? VI, volume of body immersed. Now from here, what is M? M is 2. It will now be equals to, do we know P subscript L? That is the density of the liquid. No. So I will leave it as P subscript L times what is the volume of the body immersed? It was what? 5 times 10 raised power negative 4. Is it not? Now good. Now we are looking for PL. How do we now do that? Divide both sides by what is attached to PL. So everything here will now be over 5 times 10 raised power minus 4 over 5 times 10 raised power minus 4. This one will cancel this one. So PL will now be equals to 2 over 5 times 10 raised power minus 4. Or like I said, this 5 times 10 raised power minus 4 is the same thing as what? 0.0. No, 0.000. How many 0? 4. 0.000. So 405. 0.000 then 5. If it was 5 times 10 raised power negative 3, I would say 0.005. If it was 5 times 10 raised power minus 5, I would say 0.00005. Are you seeing that? So because it's raised power negative 4, I will say 0.0005. Are you seeing that? Good. Now, I can now say is equals to 2 over 0.0005, and that will now give me what? Let's work it out with a calculator. 2 divided by 0.0005, 40. So that gives us exactly 4,000. And guys, what is the unit for density? Because they said determine the density of the liquid. Density is what? Always in what? For standard unit, it is in kilogram per meter cube. And this is the answer to the question. Kilogram per meter cube. I hope that is clear. So let's go straight to the next question, okay? Now let's see how we are going to solve this. Now the question reads, the density of 400 cm³ of palm oil was 0.93 gram per cm³ before frying. So before the oil was introduced to it, it has a density of this and a volume of this. Then I said if the density after frying was not this, okay, and then I said assuming no loss of oil due to spilling, because normally in real life situation when you are frying, some oil are bound to spill out, is it not? Now assuming that error does not occur, that is the mass of oil before and after are the same, is it not? Because if the mass of the oil before was this, let's say 10 kg, it's expected that after frying it should also be what? It should also weigh 10 kg. That's what this line means. Assuming no loss of oil due to spilling, its new volume was or will be. Now we have to find the new volume. Now if you observe, this is a comparative scenario before frying and after frying, is it not? Now what is constant here? Is it not the mass? Because they said assuming no loss of oil. Assuming no loss of oil, determine the new volume. But first thing first, let's derive. What was given? The density of 400 cm³. 400 cm³ is what? Volume. So let's call that, let's say V1, or you say V before frying. In short form, V1, that is V initial, is it not? They said it's what? 400 cm³. And we cannot work with this form. Now, from cm³ to meter cube, you divide by what? 1 million. And that will give you, if you do that, that will give you 4 times 10 raised power negative 4 meter cube. Or you say what? 0, because of this raised power minus 4, you say what? 0.00004. Are you seeing that? Because of this negative 4, you say 0.000. That's 40. Then what's the number here? 4. That's how you now write it. That's another form of writing this. Now, then I said The density of 400 cm cube of palm oil was this. So the density before frying, I will call that P1 is what? 0.93 gram per cm cube. Now this is not the standard unit for density. But why am I not going to convert? I am comparing. So this guy, though it's not standard, is bound to cancel. This gram per cm cube, though is not the standard unit for density, because there's also a similar of such. If gram per cm cube is on this side of the equals to, and gram per cm cube is also on this side of the equals to, the normal logic is that gram per cm cube on this side, we cancel gram per cm cube on this side. So there's no need for even me to convert it to kilogram per meter cube, which is the what? Standard unit for density. So that is the mathematics. That is what happens when you solve question over time. You'll not be seeing some shortcut. There's no need to convert it. Let me leave it like that. It will definitely cancel out. I hope that is understood. So we continue. Then I said, if the density after frying, so that will be P2 because it's after the frying. They said is what? 0.6 gram per cm cube. Okay? So we continue. Then I said, assuming no loss, that is the mass before is equal to the mass after. This is what it means mathematically. Assuming no loss of oil due to spilling, the new volume, that is V2, will be what? Unknown. V2 is unknown. Now, based on what they said, assuming there was no loss of fluid, that is the weight of the oil before frying, must be equal to the weight after frying. I will start from there. M1, okay, is equals to M2. Are you seeing that? This is what is constant in this very comparison. Before frying and after frying, there was one thing that was constant. You know one thing about comparison? You should be able to look out for that thing that will remain constant. It's from there you can now start expanding. In this case, mass remain constant. Now, there is another thing I can do. Instead of mass, because this question is talking about density, relative density, but in this case, density to be specific. Is there any formula for density? The formula for density, like we know, is what? Density is equal to mass over volume. Now, because M was said to be constant, can I express M in terms of density? M will now be equal to what? P times V, is it not? So in place of M, I can say PV. But in this side, P1, V1. It's equals to, in place of M, we said whenever you see M, put PV. But because the M is carrying 2, I will say P2, V2. Now, I have succeeded in expanding from what was constant and expanding it to include what was given. That is how it is with comparison case. Now, from here, I will now ask myself, were we given P1? P1 was given as what? 0.93 times, were we given V1? In the standard form, it was given to be this. But the form I would like to work with is the decimal form of 4 times 10 raised to the power negative 4. And that is what I have taught you how to get it. What is the power here? Negative 4, is it not? So because it's negative 4, I will say 0.000. How many 0? 4 0, is it not? Then what's the number in front? 4. That will now be what we end it. So in place of this form, I can say 0.0004 equals to, are you seeing that? When we given P2, P2 was given as 0.6 times, when we given V2, that is the unknown. So I'll leave it as V2. Now observe something, guys. Observe something. If I have, now let's see why I said you should have not convert, because this is a comparative case. You most times don't need to convert the units. Now, we know that this guy, 0.93, on this side of the equation is actually having a gram per cm cube as the unit. While this guy, 0.6, on this side of the equation is also having a gram per cm cube as the unit. So what is the normal logic? Gram per cm cube on this side, we cancel gram per cm cube on this other side. Is that easy? You have to be very, very logical with physics question in order for you to be faster. While some people are actually converting this to kilogram per meter, you already see beforehand that they will definitely cancel out. So there's no need for me to convert. I hope that is clear. So from here, what do we now have? We can actually time this out, but let me just go to the point. We are looking for V2. You can choose to do this first, to times it first, then continue. Or let me just do that. Then, okay, let's continue. We are looking for V2. We can say divide both sides by what? 0.6. You know what about physics and mathematics questions? There are many ways to arrive at your answer. Okay? There are different approach. And all of them, provided you do not miss the step and the rule guiding it, you definitely get your answer. Now let's continue. We are dividing both sides by what? 0.6. So 0.6 here, we cancel 0.6 here. What is left on this side? V2 is equals to, what do you have? 0.93 times 0.0004, everything over 0.6. So we'll be getting a single answer for this now. Let's see what our V2 is. Let's see what our V2 is. Now, funnily, there would have been no need for me to actually convert our V1. Check. There would have been no need for me to actually convert our V1 because it's what? A comparative case. I hope you remember that. I could have actually leave it as 400 cm cube. Then the answer we get will also be in what? In cm cube. So whenever you have a comparative case, there's no need actually to convert. So what I have now will be in meter cube. Then I will now have to convert it back to what? Cm cube. Because the option in this case will most likely be in cm cube. Because whenever they are comparing, they expect you not to convert anything. Most case. So let's do this times 0.93 times 0.0004, okay, divided by 0.6. This is what I have. 0, okay, 0.000 then 62. Now this guy is in what? Meter cube. Now because the volume was given in cm cube, that I said there would have been no need actually for me to convert this cm cube to meter cube. Why? This is a what? Comparative case. Before frying, after frying. In JAMB and pursuit tell me, because it's a comparative case, you will see the option in cm cube. So why should I have converted in the first place? It wasn't even necessary. So I will have to convert back. That's the stress that most students will face. Because they don't know that in comparative cases, most times don't convert the unit, just solve like that. They will solve and get in meter cube. They will not be facing the extra stress of what? Converting back to cm cube. Because JAMB in most cases, we just simply leave their options in cm cube. Why? It's a comparative case. So let's face the extra stress of converting back to what? Cm cube. How do you do that? From meter cube to cm cube. Remember, from cm cube to meter cube, we divide by 1 million. Now, from meter cube to cm cube, we times by 1 million. So let's now times our answer by 1 million. Okay? When we do that, we have exactly 620. And this is what you see in the option. You will see something like 500. You will see something like 500 cm cube, 600 cm cube, 620 cm cube. And the answer to the question is what? 620 cm cube. So guys, I hope you understand how all these questions today was solved. Basically, I hope you understand how they were solved. Thanks for watching. Don't forget to share my video with your friends. See you guys in my next video.